Hello and welcome. In this session, we are going to explore the core areas of artificial intelligence, the key domains that power the AI systems that we use today. The entire module, you are going to understand how machines learn to how they see, listen, and understand the natural language of human beings. We'll break the entire module into smaller, simple topics which can help you to learn these topics in a practical way. We understood earlier that AI is about teaching machines to think and act intelligently, just like humans. But AI isn't one single technology. It's a collection of multiple subfields working together. So we'll focus on the major areas of artificial intelligence, which are machine learning, deep learning, natural language processing, computer vision, and speech AI. And each plays a unique role in making machines smarter. Then finally, we'll also understand how all of these fit together in a particular way. Now let's look at these broad core areas of artificial intelligence. This is a snapshot of the key areas we'll be exploring in this particular module. Machine learning. This is all about how machines learn from data. Deep learning. This is about neural networks mimicking the human brain. NLP, understanding and generating human language. Computer vision is all about making machines see the real world like the way the humans see. Speech AI is about enabling machines to listen and then speak. So if you look at the entire area of AI is all about replicating the human intelligence in machines. Can I make a machine think and act and behave like how humans do? Machine learning is a subset of AI where we are enabling the pattern recognition, which is a critical component of human intelligence. We are enabling it in a machine. Deep learning is all about replicating the human brain and the biological nervous system in a machine. Gen AI is all about generating data. Then NLP is about understanding human language. Computer vision is about creating machines that can see. And speech is all about enabling machines to listen and speak. So this is how all these are interrelated. Of course, we're going to learn more in the upcoming sessions on each of these areas, and you'll be able to understand this better. And you can connect this to the real world Gen AI applications that you're seeing today too. Thank you. See you in the next session. Hello and welcome. It's time to discuss about machine learning. We understood machine learning as a subset of artificial intelligence. Here, we are taking the learning ability of humans, intelligent humans, and we are giving it to a machine. It is all about making machines learn from the data and make decisions without being explicitly programmed. So, if you look at it, it is more about decoding human patterns, the pattern recognition concept of human intelligence, and encoding it to a machine. So, it's all about making the machines learn from the data so that you're able to take decisions, make predictions, and importantly, without any explicit programming. How does this work? You feed the machine with historical data, like for example, the past sales records or customer behavior. Then the algorithm learns patterns from this historical data. This is where the role of statistics comes into picture. The statistical algorithms, ranging from linear regression to advanced models, you can use it to decode the interesting patterns that exist in the past data. Then with those patterns, the machine learning model can actually predict future trends, like what customers are likely to churn or what product might sell well next month. This is how machine learning works. In fact, think of it like teaching a child to recognize fruits. Show them enough apples and bananas, and eventually they can identify new ones on their own. Now let's understand the different types of machine learning. So when we talk about machine learning, we can start with supervised learning. The supervised learning is trained on labeled data. So you have the past data that is available as input output pairs, clearly labeled so that you can see the relationship between input and the output. By deriving the relationship between input and the output, the model is able to make better predictions. Example, email spam detection. With every email passing through the server, the customers labeling them as spam or not spam. This acts as a training data for a machine learning model to recognize what is a spam and what is not a spam. So when a new email comes in, it looks at which pattern this email is matching. Is it a spam pattern or not a spam pattern? And accordingly, the mails are labeled and classified. So supervised learning works in this fashion. Loan approval is another example. Whether the loan should be approved or not, given the set of credit parameters that have been made available for the banker to decide about the customer. Now let's move to the second one, unsupervised machine learning. This finds data, this finds unlabeled data, that is, I don't have any labels, I don't have the output available for the past input data. Here, the entire training is on unlabeled data. Now, the job of the algorithm is to find patterns in these unlabeled data. Is it going to be easy? Not. You need to find hidden patterns. So the models are slightly complex. It keeps exploring hidden patterns, and that's the reason the accuracy of these models are generally low. For example, customer segmentation. If you give me the complete past customer data, I can look at some interesting details, features, and with the help of which I can segment the customers with those hidden patterns identified. If I need to detect anomalies like frauds, for example, I can detect anomalies with the help of hidden patterns using unsupervised statistical algorithms. The third type of learning is reinforcement. It learns through trial and error, like how a robo can walk. This generally follows rewards and penalties patterns. Like you're going to help a robo to walk from point A to point B, and you're going to incentivize the bot by asking the bot to follow a certain rule. If it does it right, you're going to reward it. If it is not doing it right, it's going to get a penalty. So you're reinforcing a certain behavior for the bot to be successful with rewards and penalties. Example, if you want to teach a game to a bot, then this is the best learning approach that you can use. If you want the bot to navigate from point A to point B, then reinforcement learning is the best case. And if you want the ads to be optimized with very little data, then again, reinforcement learning can make a difference. So now we have understood the learning approaches. Let's look at the practical use cases of machine learning. Today, enterprise marketing, that is the corporates, are using the machine learning models to find out which customer may leave next. I can predict the customer churn for different companies using machine learning models. I can recommend products on Amazon. Like for example, people who bought this also have bought this. It's a very good example of machine learning model trying to find out interesting hidden patterns to recommend the appropriate product based on your purchase pattern. If you want to detect frauds in banks, then machine learning models are the best models for you to approach. And if you want to do demand forecasting or sales forecasting, then machine learning models can look at the historical data and can predict what your demand would be down the lane. So, to summarize, machine learning is the engine behind many everyday applications. We don't even notice it anymore. So, it's all included into our day to day world, right from Mother Google to the Spotify. Everyone, every app is using machine learning. I hope you have learned something new in this session. Let's connect again in the next session. Thank you. Hello and welcome. In the session today, we are going to discuss about deep learning. We are literally diving deeper to understand more about the concept of neural networks, deep learning, which is a subset of machine learning. Let's look into the details. Deep learning is a specialized form of machine learning that uses neural networks with multiple layers to learn complex patterns. It's especially good at working with images, audio, and natural language, usually the data that are messy and hard to define with rules. Whenever we deal with structured data, machine learning is good for us. But when we're dealing with huge data sets and data sets with multiple dimensions, then it's going to be tough for machine learning models to understand the patterns in it. This is where deep learning comes into picture. If I have to give you an analogy, if machine learning is like teaching a kid with flashcards, deep learning is like giving the kid access to the internet, letting them absorb everything from YouTube to Wikipedia. So the complete freedom is for the model to decode anything and everything from the data. While in the machine learning, you're just giving a very limited context for the model to learn from. So it's like machine learning on steroids. That's how deep learning works. So how it works? This entire concept of deep learning is inspired by the human brain's neurons. So we are trying to replicate a biological nervous system of a human being in the form of a artificial neural network in a machine. A biological neuron is being recreated in a machine in the name of perceptron. So the deep learning uses artificial neural networks to decode everything that is being done. So deeper layers learn higher level of features from the data that is available. But one important thing, the deep learning is still like a black box. We may get excellent results, but the problem is we do not know how it works really inside that black box. Many times explainability is a problem. Let us understand neural network frameworks better. I'm going to explain to you some of the popular neural networks that are available here. So deep learning uses ANN, that is artificial neural network, designed to mimic how neurons work in the human brain. With more layers, the model can computers coming into action. So the power of AI comes from integration. The real power of AI doesn't come from